Assalamualaikum and good day. My name is Junaida binti Sulaiman. My metric number is CN180128. I am currently in my 4th years of Bachelor in Mechanical Engineering Technology, Manufacturing, and my final year project title is Semi-Automatic Pneumatic Actuated Otak-Otak Pin Insertion Machine. Before going any further, I would like to thank my supervisor, technologist Dr. Muhammad Farid bin Syari, and my co-supervisor, Dr. Salwa Mahmud, who have assisted me throughout this PSM journey. Thank you to them for their trust for me to carry out this project by sharing their expertise and encouragement from PSM 1 until PSM 2 today. As everyone knows that otak-otak is a popular food in Johor when it is served as an appetizer in almost all eateries and restaurants. This caused the demand for the otak-otak to increase. Currently, the process of pinning bamboo skewers to attach nipah leaves is done manually by the workers. So in this project, the purpose is to create a mechanism that can hold and pin the otak-otak at both ends simultaneously. The scope for the otak-otak is the one that used the nipah leaf and bamboo skewers as the wrapper. The SolidWorks software is used to design, analyze the structure, and simulate the function of the pin insertion mechanism. The pneumatic system is also embedded to the mechanism, which the pneumatic circuit is designed by Festo Fluid Sim software and empowered using programmable logic controller PLC. The mechanism of the pin insertion machine was determined with the element provided to hold and bend the wrapped otak-otak to be pinned without having to be held by the operator or the worker. The machine, complete with a pneumatic system and PLC components, was developed and tested to be operated as desired. The overall dimensions of 300mm times 400mm times 300mm of the additional bending unit have been attached to the existing machine structure, which the total structure dimensions is become 1000mm height with 500mm times 500mm for the base structure. The machine has also been ensured to function optimally at an input pressure adjustment of 0.2 megapascal that operates at 3.87 seconds based on standard time. In the introduction, currently in market there are two types of otak-otak. The one that is wrapped using nipah leaf and the other one is wrapped using popiah skin. This study focused on the otak-otak that wrapped with nipah leaf and pinned using the bamboo skewers. Figure 2 is the complete production process to produce otak-otak, starting from cleaning the fish, filleting, grinding, mixing with spices and coconut milk, wrapping, packaging, and lastly storage. When looking at wrapping station, one task involved, which is to fill the otak-otak into nipah leaf and then to wrap it. The second, workers need to pin the bamboo skewer at both ends, which is time consuming and created a bottleneck in the production. The bottleneck exposed the fish fillet to the environment, which have the risk to get contaminated. As for the literature review, previously there are many researchers show their interest in innovating the machine to produce the otak-otak in order to help the SMEs to grow their business. After all, the government has allocated the budget that comprises the automation and digitalization facility, which will provide the SMEs with an 300 million ringgit incentive to implement the automation and digitization to boost production and efficiency. Therefore, the main goal of this research was attempted to design and fabricate a semi-automatic otak-otak pin insertion mechanism that could help in increasing the otak-otak production rate. This study mainly referred to the previous otak-otak machine that has been developed by Tonison in 2017. The machine developed by him is using a pneumatic system to pin the wrap otak-otak simultaneously at both ends. The worker need to hold the wrap otak-otak in the holder, then step on the pedal to activate the mechanism of pin insertion. Referring to this figure, this is the flow chart of the process to develop the machine, starting from developing the design concept using a scamper and morphological technique, creating the model design and do the FEA and simulation analysis of the models, developing the pneumatic circuit and electro-pneumatic program using the CX programmer, fabricating and installing the circuit, and finally performing the test to validate the machine operation. The FEA or finite element analysis method used to analyze the structure for bending unit which act to hold and bend the wrap otak-otak into the holder. Figure 3 shows the setup for the experiment to determine the optimum input pressure that able to pin the bamboo skewer into the nipah leaf. The pressure sensor model SDE1 by Festo was used to measure the pressure in the cylinder that involved in pin insertion task. After setting the input pressure, the wrap otak-otak was placed on the holder. The push button was pressed and the observation was made. The pressure value from pressure sensor left and right were recorded. The bending and pinning time were also observed and recorded using stopwatch, and the process was repeated in 3 times. This is the results that were obtained from the method used. The first result is the static analysis using finite element method or FEA in SolidWorks simulation. 3 models for bending structure were designed in order to select the best design structure that will do the bending task for the wrap otak-otak being pinned. In the first model, it is a frame-like structure with the top and side covers. The pressure from the cylinder act upward on the middle of the top cover. The second model was designed with the aluminium bars act as a pillar and a beam to hold the bender unit. The pressure from the cylinder act upward on the most front of the top beam. In the third model, 3 aluminium bars are involved where 2 bars act as a pillar and a longer beam is used to hold the bender unit. The pressure from the cylinder also acts upward on the most front of the top beam. In this analysis, the material used was aluminium 6061, which is the most material used for kitchen equipment. The pressure value is 0.2 megapascal, which is the minimum pressure for clamping. And the mesh used are standard or standard solid mesh type, with the element size is 5 mm and the tolerance is 0.25 mm. The first model shows the maximum value of stress, displacement, and strain, which are 691.924 megapascal, 10.798 millimeters, and 0.005 respectively. When the design changed to the second model, more displacement occurred at the back of the beam with a maximum value of 0.0951 millimeters and the maximum stress is 5.608 megapascal. There is also a moment on the pillar that causes it to rotate in the direction of displacement. Using 2 pillars as in the third model, the smaller displacement occurred at most front of the beam, which shows a maximum value of 0.0128 millimeters and a maximum value of stress is 3.652 megapascal. Based on the results, the third model design has been selected as the final design for the Otak-Otak pin insertion machine. As the FEA analysis shows, it has a lower value of stress and displacement compared to the first and the second design. This displacement can be reduced or eliminated when gussets are installed as fasteners between the beam and pillars. In figure 5, it shows that the pressure that needs to release the cylinder was always lower than the pressure to retract it. The output pressure were directly proportional to the input pressures. Referring to figure 5, based on the behavior of pin insertion result, the most suitable input pressure is 0.2 megapascal because the skewers were securely pinned at both ends of the wrap otak-otak for every cycle. This is the minimum pressure that needs to be set before the operation, which will optimize the operation of the machine while minimizing the use of energy. In figure 6 shows the forces value that also shows the same trend, which is a higher force required to release the cylinder, except for the first pressure setting where the force to retract the cylinder is slightly higher than the release force. So for 0.2 megapascal input pressure, the force needed to securely pin the otak-otak is 59 Newton. From the last chart, the normal time for electro-pneumatic pin insertion is 0.25 seconds, higher than the semi-automatic method, while the standard time is 0.3 seconds higher as to compare. This is because there are two operations done by the newly developed machine. The total time involved the movement of the bender unit to hold the wrap otak-otak into the holder, and the pinning unit that pins the bamboo skewers into the nipah leaf. Compared to previous project, Compared to previous semi-automatic method, the time was recorded only for pinning process. Although there are only small time interval differences between semi-automatic and electro-pneumatic methods, the electro-pneumatic pin insertion mechanism would be the best solution for the otak-otak wrapping process because it was able to eliminate the risk of injury among operators. No longer need to hold the wrap otak-otak by hand while pinning the bamboo skewers. The process would also speed up as the wrapping process can be done during the pinning process, which is done automatically by the machine. As for the conclusion, the project was successfully achieved its objective. The first, the design concept of a semi-automatic electro-pneumatic otak-otak pin insertion was determined, with the bender used to hold and bend wrap otak-otak to the holder by a couple of 50 mm stroke double-acting pneumatic cylinders that help to make the pinning process easier and safer. Secondly, the machine structure was developed embedded with the pneumatic system and powered by the PLC, with the whole dimensions of the structure are 1000 millimeters in height with 500 millimeters times 500 millimeters for the base. And the machine operation was verified to be operated at the minimum input pressure of 0.2 megapascal, with the standard time to hold and pin wrap otak-otak in 3.57 seconds. That's all. Thank you.